Well, hello, colleagues. Thank you all so much for joining us today. I'm Eric Richardson, the president of INHR, one of the sponsors of this event, and you'll see the logo of the other sponsoring organizations listed on the slide behind me. But let me welcome you all and tell you we're very excited today to be launching at the Biological Weapons Convention, INHR's recommendations for government on how to make applications of AI and synthetic biology safer, especially in the context of biological weapons risk. I think you've been handed out a copy in English of the recommendations themselves. The QR code on the slide also will let you download it if you find a digital version easier to carry. And let me just say that those are the product of an international expert group that's been working for really 7 years on different aspects of improving safety and security of AI applications, mostly in military and security context. The group includes lawyers, scientists, policymakers, former diplomats like myself, former military officials like General Panwar, and of course, biologists. They come from countries as diverse as China, Russia, India, Europe, and the United States. And despite the political differences between their home countries, as experts, they've been able to agree that governments urgently need to undertake measures like these in order to reduce some potentially catastrophic that could arise from AI and synthetic biology, especially in the military and weapons spheres. So today's the launch of these recommendations, but I know there are many new colleagues and new friends in the room, some from civil society organizations, some from government delegations. And so to the extent that you're also a civil society group that's interested, or if you like what you hear today, they're open for endorsement. You'll see on the last page or the penultimate page of the document in front of you, the list of about 20 organizations that have sponsored from around the world. Almost every continent involved, but if you want to be our first endorsement from either Antarctica or South America, we welcome you, so please do. Also, Sean, who's sitting next to me, is the person who's been coordinating the compilation of endorsers. So he can be reached at Sean, S-E-A-N, at INHR.org, and we'd be happy to follow up. As you see on the slide now, I mentioned that these recommendations were developed by an interdisciplinary group of experts from a range of countries. The group has been meeting online and in person going back to before the pandemic in different countries in order to analyze different issues of risk caused by the convergence of AI and military systems. Today, in fact, in Geneva, we're starting a 3-day meeting looking at agentic AI and its impact on the military. And in this process, I think our experts have reached one overarching conclusion, which is there's no one-size-fits-all answer to address concerns about artificial intelligence security. In fact, what you need to do is look granularly at the issues you're concerned about and figure out what risks you feel are of concern, and then figure out how to mitigate those risks. So, and our group worked through a process, which we did on the AI and biology and other issues, where we start out with scenarios in education, then moving to international discussion of the legal, the diplomatic, the political, the scientific implications, to come up with practical suggestions of actions that all of the governments involved can agree with. And if one country thinks, no, that wouldn't work in my country or my national context, we take it off the list. Next slide, please. So with respect to AI and synthetic biology, we have kind of 4 categories of recommendations. They're listed here. The first is kind of improving human capacity to manage AI and synthetic biology, including training for governments, red teaming approaches, motivating the private sector to come up with better guardrails. The second involves technical solutions such as safety evaluation, testing, greening policies, and industry best practices. The third involves national governments making the same kind of interdisciplinary connections that we do among experts, among ministries or government groups, between biological agencies, law enforcement agencies, national security and counterterrorism agencies in particular. And last, what we're here for today, international cooperation, like creating mechanisms in bodies like the BWC to help states better address these kind of cutting edge risks of AI and bio. We hope that states feel that the kind of information we're sharing is useful, and we'd be happy to cooperate with any mechanism the BWC creates to assist states. We also help states on demand, and we've done trainings for countries ranging from Nicaragua and Gambia in Africa, India, Pakistan, and China in Asia, and other parts of the developing world. But with that, you didn't come to hear me, you came to hear from our speakers. So let's hear from them. First, we'll have three speakers. Dr. Zhangwei Wen of Tianjin University will open, talking about the convergence of biotech and artificial intelligence. For those of you who don't know him, Wei Wen is a world-renowned expert in biosafety, and he'll speak about how some of these recommendations are actually in the process of being implemented in China. Then we'll have Dr. Anita Cicero, the Deputy Director of Johns Hopkins Center for Health Security in the United States. Anita will talk to us about the needs to address these biosecurity risks, and she was one of the primary authors of the recommendations. So she'll describe several of them in more detail than I have in this slide. And last but not least, retired Lieutenant General Dr. R.S. Kanwar of the U.S. Institutes of India, United Services Institutes of India, will discuss more about what I was saying, why we need a granular approach to address AI and biorisk. He'll also talk about counterterrorism concerns that arise at the confluence of AI and biotechnology. So with that, let me turn the floor over to Zhangwei Wen, and we will make sure we have time at the end for questions. So if you have questions, please be thinking about them. Over to you, Wei Wen. Thank you.
Thanks, Harry. Good morning, everyone, and welcome to our event. And my name is Wei Wen Zhang from Tianjin University of China. And in the next probably 8 to 10 minutes, I will talk about the AI biosecurity challenge, and also, as Eric mentioned, some of our recent efforts in China to work with those kind of issues. Next slide, please. Okay, the AI development, especially, I guess, almost exactly 3 years ago, and JustGPT was released, really and significantly reshaped the way we are doing the bioresearch. I think from the early one, like large language model can provide information and guidelines to the research, to the prediction of the protein structure and the protein structure interaction, to recent biological design tools to support novel pathway or molecular design to into the future in the automation of the bioresearch. Everything. It really has a very profound impact into the future bioresearch. Next one, please. Okay. Meanwhile, I think people also realized with the new technology, very powerful technology, have some really big challenges to the biosecurity. We can pretty much divide them into two categories. One is the sort of traditional biosecurity challenge we've been talking about in the last 10, 20 years, but with AI, will tend to challenge get accelerate or amplify. Like the first two I mentioned here, AI basically increase the possibility for unintentional technology misuse and also reduce the barrier for delivery of the technology. But more seriously, in the future, I think the AGI and probably some people are thinking in the next 3 to 5 years time, and will generate novel biological knowledge. Those knowledge could challenge current government principle of we are using to define this word. So those are the things we really need to take into consideration when we think about the future. I will give two very detailed study conducted in last year, published in this year. If you look at the left panel, and the people found that with all the technology integration and the new foundation model, all that, and if you test them with some of the bioweapon construction, and they actually give you very good. You can see that even within the last 3 years, those kind of large language model have very increased their capability to deal with GPU guideline and computing and everything. And also, if you look at the right panel of this presentation, and you can see that people pretty much examine the large language model and making prediction that how good it compared with the top expert in the field, and they predict most of the large language model will be as good as top niche scientists in the next 5-10 years. My guess is probably even quicker. And so for those kinds of challenges, really, everybody working in the field that we need to really think about what can be done and to safeguard the technology application, the research and the application in the future. Next one. So along this line, I think as Eric just mentioned that we are also part of the team working with the recommendation which will be released. But in China, we are also working very similarly. This is one of the domestic effort we've been working, and we called it working by the Cambodia AI and all universities together. And we released a report we called Responsible Innovation of AI Bio. And in this report, we identified a couple of areas we recommended to our ministry, several administrations in China to really take action. One is start to build a national and international mechanism to the risk assessment, and also start to develop the management framework to deal with AI risk. And finally, even for some of the catastrophic cases, we have need to start work on some emergency plan. So we released this report during the World AI Conference in Shanghai in July. And since then, I think we've been contacted by many of the agencies in China to look into this report. The next one, please. Then also, in addition to the policy, also the technology is also a way to deal with those kind of issues. If you are not familiar with this presentation, this is a very typical, we call the DBTI cycle. That's for the synthetic biology. Also, for most of the cutting edge biotechnology research, basically you're starting from design and then start to build something. You build a molecule or DNA, then you test whether it will work, then you nourish how well it will work, then you go around the cycle. So we've been advocating that in China we need to build a technology safeguard along this cycle, and they're very glad to tell people that in the next 5 years plan for the national 5 years plan, and we will start to roll out some of the projects in this particular area. So you can see that through this cycle, actually, AI big part of that. For example, the design part. I mean, in the past, it's all mostly depends on the scientists to make the design, but in the future, AI will be a big part of that. And in the building phase, the DNA synthesis screening is also a very hard topic. You probably heard that many times during this. So it's also part of that. Next one. And also very glad to report that this slide is prepared by Professor Xingguan Zhu from Chinese Academy of Science. And Xingguan is a leading plant synthetic biologist in China. It is also leading the strategic planning for AI bio by Chinese Academy of Science. And this work is still ongoing, but Xingguan is not able to hear, but he make this slide for me, and basically just showing the support that he and his team basically supporting the basic research on AI biosecurity, and hopefully that will be also you can also see that in their strategic planning for 5 years for the Chinese Academy side. And also they support the government action on the AI biosecurity. And the Xingguan is actually all the people actually endorse the recommendation. That's probably also worth mentioning. Again, also that regarding the risk awareness of the industry on the AI biosecurity, and the Xingguan, and me, and probably Eric will be also interested. And we are actually thinking have next year and engage industry into this discussion. The next one. So when we talk about the awareness week reading, I cannot help to to show this slide that many of our in this room, I think, have been working on this document called Tianjin Biosecurity Guideline. And that's 2016, and initially submitted by the delegation of China and Pakistan. And of course, through the years, many contributions from many people in this field, and in a long review conference, it was accepted very well. I'm hoping that, with the new challenge of AI, I personally believe that this document will become more relevant to deal with some of the challenges I just mentioned there. So I'll be very glad to have the opportunity to talk with you all on this. Okay, and then I will stop here. Thank you all.
Thank you so much, Weiwen, and thanks to Tianjin University for being one of the original endorsers of the recommendations being released today. Our next speaker is one of the primary authors of those recommendations, Dr. Anita Citra from Johns Hopkins University. Anita, over to you.
Thank you so much, Eric, and good morning, everyone. As Eric said, I'm from the Johns Hopkins Center for Health Security, and our center was formed 25 years ago, a little bit before the anthrax attacks in the U.S., and our mission has been always to protect people's health from large-scale biological disasters. So we conduct independent research and analysis and offer recommendations for governance for advanced biotechnology as well. Next slide. So before talking about the recommendations, I wanted to spend a moment talking about why this group decided it was very important to provide some recommendations to nations about governance of AI bio and its conversion. As we have all seen in the 3 short years that Weiwen referred to, AI technology, the capabilities have made very rapid and actually hard to predict jumps in capability. Where we are right now is there has been a qualitative change in national security risk. It's not just an incremental continuation of existing trends, but this is something that is important to pay attention to. And if we look to the leaders of the most advanced frontier AI models, they're telling us the same thing. They all have, or many of them now have safety networks where they're evaluating their models and reporting back on safety and trying to make interventions or mitigations if the models exceed certain thresholds for safety. And every one of those frameworks talks in particular about biological threats. There are other issues that the models are looking towards, obviously, like bias and privacy issues, chemical and nuclear threats. But the thing that rises up above the others in terms of their concern is in the convergence of AI and bio. OpenAI's preparedness work anticipates that future models will reach a high biological risk tier, which they define as their ability to provide meaningful assistance to novice users in creating biological threats. And they reported that out in June of this year. Anthropic in May has also stated that its most advanced models require special safety restrictions because of an elevated risk that they can assist in developing biological threats. They are taking both companies like a precautionary principle. They're not saying that the most dangerous models are here now, but they're already showing signs of being able to exceed benchmarks, expert performance benchmarks of humans, particularly in molecular biology. And Anthropic has also said just this December that the growing body of evidence about these biological risks from AI models means that AI developers and policymakers must attend to this now. So I think that's one of the reasons why we thought it's important to try to come together in an international group and talk about what recommendations should be made. Next slide, please. I also wanted to take a moment just to talk about or piece apart like what AI models are. On the right, you'll see the large language models that people are familiar with, the ChatGPTs and others. And these ones are multimodal reasoning models, also agents, and eventually at some point artificial general intelligence. These large models are trained on natural language, video, audio, scientific papers, and even sci-fi fiction. They're trained on, they suck up everything. On the left are more narrow AI tools for biomedicine application, and they're trained on biological data directly rather than the summaries, human summaries of that data in scientific papers. So their language is genomic sequences, protein structures, functional data. Generally, these are smaller models trained for specific purposes to be used as tools, usually in academic labs, not in the large language model companies, although there's continually a merger of those two. But now we are also seeing there in the middle an overlap between the right and the left. And they're very large bio-foundation models, frontier biological AI models that have the same or more compute power than many of the highly capable LLMs, and able to read and write DNA and RNA just as the large language models work in natural language. And we're seeing an integration too, so of LLM with this kind of AI, and a lot of interest and investment too in the US of generating additional biological data to train AI models, to invest in cloud labs so that there can be scientific labs with many robotic parts and automated to work 24/7 on scientific experiments. This is all very exciting for the future of advances in biomedicine, but also has a risk attendant to it. Next slide, please. Just some examples of how the convergence of AI and bio can increase bioweapons. It can help to accelerate weapons design, optimize pathogens, reason over vast amounts of biological data to sort through and potentially find pathways by which certain pathogens could be made more transmissible or more virulent. It can help automate experiment design and interpret wet lab protocols in ways that may be usable by more actors and also non-specialists. So things like optimizing viral vectors, generating complex genomes that evade natural or vaccine conferred immunity, going through high throughput data generation methods to look for viral transmission rates. And one of the things that I don't know if it's not like the top of the list, but is I know worrisome to many is the potential design of proteins or genomes or genetic pathways that would confer specific susceptibility on specific human ethnic groups. So again, this is sort of the kinds of risks that in the future we're worried about. Next slide, please. So one of the challenges is that right now there is little to no national governance to limit these risks. There's no international standard or norm. I just came earlier this week from an OECD meeting where they'll be putting out a report to try to give guidance to OECD member states on this. We've obviously seen the international AI safety report that Weiwen referred to, et cetera, but there's not enough attention to this in terms of the governance side. We also have, the AI race of, who will get to the finish line first, although I don't think that is the appropriate way to be thinking of it because everyone's moving towards the line and goodness to pass the line. There's nothing magical that happens at the end of the line. And we want to reap the incredibly transformative benefits from AI. So I think that unfortunately, and I'll speak just from the US perspective, there's this reluctance then to try to address on the risk side. Next slide, please. So that brings us back again to the recommendations that we prepared for governments for consideration. And this slide just says some of the principles that underline our recommendations that it's really important to pursue AI technology in order to be able to reap the benefits. It truly can be transformative for human health, for the environment, for climate, et cetera, and manufacturing and everything else, but also can produce these profound risks. An important aspect of these recommendations too is that it acknowledges that there are a lot of risks with all technologies, and there are a lot of biological risks that could come from the convergence of AI and bio. We weren't trying to attack all of the risks or address all of those risks, but the message is at least address the highest consequence risk first. Or maybe only for a while address the high consequence risk as we pursue the technology worldwide. And the other important thing, obviously, is that government has a unique role to play. Obviously, it needs to collaborate closely with industry. It will be able to address these risks, cover them, or maybe even reap the full benefits of them without collaborating. Next slide, please. So the overview of the recommendations, you'll see in front of you or in your QR code that they are packaged under like awareness raising and training. That first one, and that is really the acknowledgement that countries really need to have technical capacity in order to be able to govern or make the best use of AI. And this is lagging everywhere in every country. And so there needs to be an investment in workforce. There needs to be models of trying to collaborate with the industry on these issues. Next section is on safety evaluation, testing, and industry best practices. There are a lot of groups that are in, especially in the major group in the large language model area, Frontier Models Forum, they're doing excellent work, and I would recommend going on their website. They have done a lot of work in looking through the different kinds of safety evaluation, which ones have been shown to have some evidence of actually working, which ones don't work, which ones need to work for large language models versus biological design tools. And there's an interest in sharing best practices on safety evaluation. So the evaluation of safety of models is a nascent field into itself. So there's so much more work that needs to be done there. It's not just that the safety measures are ready to be applied. Bother to apply them. It's more that we need to have an evidence base to understand if these different things work. Can you train a model with certain data and then unlearn that data out of the model once you realize that it had dangerous capability? It's unclear if that works or it doesn't work, and that's true across many different kinds of safety evaluations. So this section of the recommendations talks about some of the measures and the importance of sharing those best practices. And then I will talk about national governance and international cooperation in the next two slides. So if you forward, thank you. And examples of national governance measures. Large companies are already performing kind of risk assessments and safety evaluations of their models, and also they do their own safety evaluation. Many of them then either within groups within their companies or outside consultants have their model team to see if the outsiders can jailbreak the safety and get around the safety aspects of the models in order to encourage the model to do something harmful so that they can therefore patch that vulnerability. That is something that's not, that really should be required or be considered to be required or to really have government work very closely with industry to make sure that they're doing it and to learn from industry again about what measures work and don't work. On the biological design tool side, that's a different beast from the large language models. As I said, large language models have you train them with a lot of data, and then it's unpredictable about what capabilities they may end up with. That is not the case for the large biological design tool, because you sort of are, it's like a scientific experiment in some ways. You're setting out with a certain goal to try to get to a certain capability at the end of the work. And so these models are trained specifically to have the kind of capabilities they have, which in the end could be dual use. So there's an opportunity there to do a pre-development risk assessment. And that's something that we mentioned in the remedy. There's also an interest in government's understanding, and again, working with industry about, like, once you realize there's a red line crossed in terms of safety, what mitigation measures should be put in place? What is appropriate? That's not something that is well understood or known. Also, the governance of highly sensitive biological training data, and this is something that the state parties potentially through an FFP review mechanism could look into, because obviously biological data should be shared broadly as possible while protecting privacy and also making sure that dangerous national security kind of implications of data is not broadly shared. But the training data is really everything for biological AI models and for LLMs. And there's a great interest, as I said, in generating more data and standardizing data in order to train models. So there's an opportunity to think about whether there are certain data sets that should be used in the training. And then there's also just the financial incentive. I mean, the train is rolling on AI model development, and there's a lot of financial gain to be had. And the governments may need to think creatively about how to incentivize in various ways industry to attend to the safety of these models. Next slide, please. So what can the BWC do? One, as I know everyone always works on in these, to really strengthen the norm against the creation of biological weapons. There will be a lot of interest in being able to use AI bio capabilities in a military context, and it will become harder and harder to differentiate between, it's a crossing the line in terms of the BWC. And the BWC, the state's party, really need to become very literate on these issues in order to give guidance, make sure the norm against the use of biological weapons is reinforced, and to take any decisions that could be relevant about this in the future, because this future is coming very quickly. And so I'll end by saying it's very critical, and one of the reasons it's critical to establish an SST review mechanism within the BWC. And when it gets to the list of to-dos, which I know will be long, very high up on the list, or not first, should be the conversion to AI bio. Thank you very much.
Thank you, Anita. And our last speaker is Dr. and Lieutenant General R.S. Panwar. And I stress these two titles because, as you saw, one of our goals is to get the knowledge of both military and computer science merged together. Ravi is one of those unique people who has a computer science PhD and was a military commander. And so we look forward to hearing from you. General Panwar, please.
Thanks, Eric, and good morning to everyone. Very happy to be here. So I'll be taking off from what my colleagues given the express commentaries here. I'll be focusing on the aspect of national governance. And within the national governance, in the 22 recommendations which are part of our books, there are 5 recommendations which are in the first talks about a national policy framework. The second one talks about designating a national institution or agency as a single point of contact for AI biosecurity, national security, national health security, and national AI security. There is a high level of synergy which is required of various agencies if you have to tackle AI confluence bio risks. The next one talks about evaluating AI bio risks and design commensurate interventions and best practices. Now, this is a pointer to the risk-based approach, which Eric had alluded to in his opening remarks. And the fourth one, next slide, please. Fourth one is the elaboration on the same, identifying differentiating parameters for risks along different dimensions. These dimensions could be biosafety, vis-a-vis biosecurity, general purpose, vis-a-vis biological AI models, which Anita just talked about, and also different levels of risk, which I'll just jump to, and adopt a granular approach to going to the risk mitigation. So, much of my what I'm going to say is going to focus on the risk-based granular approach, but I'll come back to the aspect of national governance towards the end. And of course, the fifth one is to do with nucleic acid screening policies, which is central to all the AI bio risk which come. Now, granular or risk-based approach is based on the premise that while formulating mitigation measures for the wide spectrum of AI issues, what Eric also said, no one size fits all. So this is the basic premise. So let me explain with the help of the book. So there are several dimensions in which we can talk of the differentiating parameters. The first one, we've used the term biosecurity and biosafety as conjointly in many of our applications. But the way you handle risks emerging from under these two heads could be quite fundamentally different. There's general agreement that biosafety refers to the unintended harmful effects by legitimate biopractitioners. On the other hand, when we talk of biosecurity, we are talking of intentional harmful effects by rogue actors. And it is intuitively evident that risk mitigation measures aimed at legitimate practitioners will be quite different from how you tackle rogue actors. So I'll take an example from autonomous bio experimentation, which Dr. Zhang also referred to. So, for example, in the case of rogue actors, what you would do is you would be restricting access to both these types of facilities. So, access control is the basic strategy which we use for rogue actors. But in the context of legitimate actors, a totally different category of risk might arise from automation. So, whenever you automate, autonomy means that you are delegating more to machines, and when you delegate more to machines, there's less human intervention, less human oversight. So, a different category. And reference to AGI was also made by both the speakers here that when you go in for more and more intelligence, things are likely to get out of control, rash experimentation, and things like that. So, there's a different category of risk which has to be handled differently. So, this is one dimension. Biosecurity versus biosafety to be treated differently. The second dimension is which goes along how you handle general purpose AI models vis-a-vis biological AI models. So Anita just brought out that there are different categories of models. Now, how it translates to how you would handle it, that the general purpose AI model is meant to be used by the world in general for a wide variety of tasks. So it would be perfectly legitimate to build in very stringent guardrails and red teaming efforts and all, so that nothing of any consequence which can remotely also lead to development of harmful agents, bioweapons, etc. So you can lay the threshold very low and thereafter don't get any further information. Whereas when we talk of biological AI models, that's meant to be disseminated or giving power to the bio researchers. So there's no, it's very, you can't be putting in guardrails there. So the strategy there would be quite different. And that would be restricting access to the small community of researchers through licensing and other means. So that's the second dimension in which you can make a differentiation. A third dimension could be the severity of risk which is posed. Now, when we talking of the severity of risk, our recommendations are focusing on high impact, high consequence risks, maybe have a global impact. I think that was also mentioned by Anita. So one is the risk level. You could either focus on the effects. So, for example, stealth bioweapons, drug resistant superbug, highly virulent pathogens. So these are effects. You could focus on that to drop the risk levels as against more benign purposes of biotechnology. Or you could focus on the technologies. So here we have the gene drive technology, synthetic biology are the more sensitive technologies. So you can use a combination of these factors to come up with levels of risk and treat them differently. However, ultimately, what we are interested in is coming up with a risk hierarchy and treating it based on the levels of risk. But levels of risk is not the only way of differentiating things. I've already mentioned there are many dimensions in which you can go and come out with a differentiated approach to this mitigation. So that's the basic thing. A fourth thing in the same context is to do with both biosecurity and biosafety in the context of national and international security strategies. So you also have a counter-terrorism angle which comes into play. So here, rather than looking at the technologies and the tools and the process, you're looking at the actors. So you go after the rogue actors. And going after the counterterrorism angle for AI biosecurity may have a different flavor than other counterterrorism angles one might have. So that is one approach. But whereas if you're looking at how to, enforce enforcement mechanisms on the biosafety front, it would be more like regulation for oversight of how safety measures are implemented. So that's another way in which. So ultimately, what I'm trying to bring up is why are the recommendations have given out now in these 22 step, which has been which we are releasing now, is a very concise and comprehensive set of recommendations, but they are amenable for further refinement for approaching the whole aspect of AI bio risk in a more granular manner. And I'll leave you all with a last thought in the aspect of national governance, and that is to do with the concept of self-regulation. There are two ways of going about regulation. One is top-down thing. There's international agreement, and then state has to adhere to it, and there's resistance and so on and so forth. But I feel a more motivating way of going about regulation, same thing in weapons and same thing in AI bio risk, is the concept of self-regulation because the effects are going to be felt by the states themselves. Unless we are talking about rogue states, the states themselves are going to be affected by the adverse effects if regulatory measures are not taken. So a self-regulatory approach appears to be a much more motivating and convincing way to get motivated to implement these measures and regulations. That's all. Thank you.
Thank you so much to all three of our panelists. And now it's your turn. We know you're busy. You may have specific issues that interest you or questions. So any members of the floor, if you wouldn't mind being quick so we can get a lot of questions in, but we'll just turn to you, either raise your hand or raise your flashcard as I can see you around the room. Please, right here in the front. And maybe introduce yourself briefly as you start your question.
Yes, thank you very much. I'm Ayala Berman from the Asian Center for Health Security. Thank you very much for an excellent panel. Just a quick question. I was thinking about the EU AI Act, which really takes this risk-based approach, but then actually excludes narrow biological models. So what would be your feedback or thinking about that?
That's great. Let's see if we get a couple of questions and maybe group them just to give more people a chance. Our colleague from Russia, please.
Thank you all the panelists for the introspective presentation. In biology, we have to deal with very different type of information. It can be clinical data, it can be images, genomic sequences. So, how, in your opinion, the artificial intelligence model managed to deal with such technological difficulties? So it's very tough to process biological information in general, and maybe what we have in process, including the aim of revealing the possible violation of the.
Thank you so much. Let's go ahead and let those two questions come to the panel. Ravi, do you want to start on the one about risk levels, since that's been one of your interest areas?
To do with the EU AI Act. So I think the EU AI Act, another great step that must be So I think the basic concept there is the motivating factor there is human right issues. That's what the EU AI Act is doing. It is left out the complete weapons regime completely out of it. So if anything from the military domain is not covered by the EU AI Act, and so also the biological, these types of things are not covered because they're focusing on the human race. That's why I think it is doesn't take away.
If I could add that I think it's very disappointing that the UAI Act doesn't cover AI biological models, and it's understandable that it excluded sort of AI biologicals for research. But I think that but with the foundation's biological model, very large and highly capable models, I believe that it introduces the very risk that the UAI Act is trying to prevent, so that it should have been covered. And this is maybe a lesson about regulation, because I know that industry is very concerned about rigid regulation. Will be forever rules that can't change. And so it just underscores the need for flexibility. I think when they were preparing the UAI Act, the biotools were very small and specific. It didn't seem like they needed to be attended to in this. And since, and now they do. Something happens.
I'll probably just add a comment to the EU first. I think, I mean, obviously, you heard a lot of discussions, general AI, governors, really not much about AI. But at the same time, I want to highlight that actually in the industry, a lot of AI bio study and application AI related to being is developed. And it's one, healthcare is one of the areas people believe AI will play a very important role in the near term. So, I mean, for that reason, you can imagine that in a couple of years, 3 or 5 years time frame, you will see a lot of those kind of, whether it's large language model or biological design tool available. So I think it's a good time to start thinking about that. These two, that's my comments in addition to Anita's answer to you. And I will also try to address the data part from the market evaluation. To my understanding, I think you are asking how to deal with the different, especially among different countries, the question. I guess, I mean, the data obviously is very important, and the big part of the success of the future, whether language model or biological design tool. And my understanding is currently, I think almost every country has their own regulation regarding the data. For example, the China has all the clinical data and all the human data have certain law everybody needs to follow, I guess. So I don't have a good answer to your question, but I can imagine that that's the area I think needs open discussion at the UN level. I think as a professor or scientist myself, I don't think I can give a correct answer now, but it's certainly worse because we want to have a very successful AI in the future. Everybody need to be benefited for that. Then of course, how to share the data, how to get data to everybody for the public good. That need to be discussed. Similar discussion has been done with the biological diversity convention. People are talking about how to share the genomics data, and even the developing country, they are not doing much of the genomics work and get benefit of sharing of the raw material genomics data. So those kind of things are ongoing. I don't think it will be like we have an answer today, but I think it's worth attention. Hopefully, there will be more people open this issue in the future.
Thank you, and maybe I'll just add 2 points because we have 3 of what is really 65 experts in our group who are present here today. So if I can diss 2 of our colleagues, one who is the vice chair of the study that produced the EU's AI Act, Irish computer scientist Barry O'Sullivan, he often says that our process produces the lowest common denominator, and as General Panwar also mentioned, we can share with you today the point that all governments agreed on. But in the area of biosecurity, there's a lot of controversy too. So, as you know, for the EU, 27 used to be 28 states trying to agree on one principle. It's not easy, right? So there's probably a lot more detail. And the same thing that General Panwar said, there's more that we could do as an NGO group to add to the recommendations we're sharing with you today. And for the Russian colleague, I'll just say that St. Petersburg State University is one of the endorsers of this, and Ambassador Bogdanov, who's here in Russia, from Russia, here in Geneva, has been a good consultant with us as well. So you have lots of experts to reach out to, let's say that. Let me turn to the Iranian colleague and any others who want to put their flag up, and then I know you all probably want to get back to the meeting as well, so we'll make sure you get that chance. Please.
Morning. Thank you for your interesting panel. You mentioned to the creation a norm in BWC against the biological weapons. Considering two facts that we are facing to more evolving and technology-based lifestyle in the future. And the second fact that the laws usually goes lower than the technology. So my question is that in which level we can take actions in BWC context with the more compatibility with the context. For example, we can endorse and use and implement some code of conduct, for example, 10G. And the different level can be taken in the revised convention for suitable text. For example, Article 1, revising the Article 1. Which level is more better? Thank you.
I'm the one combination for governance. My background is computer science and microengineering, robotic and finance also. And my question is, there's a lot of discussions at this time about beyond that kind of stuff. How to I guess structure incentives in the future, taking everything into consideration, sustainability. How would you suggest integrating the bio risks into that framework?
Thank you for your question. I'm not sure what the answer is of which one is the best, but we should try maybe many different angles. One of the things that building on the Hinton guidelines, I think those are still essential to endorse, to share, and to promote. But you could imagine a different high-level AI bio guidelines for countries to develop their own codes of conduct to govern AI bio, or especially high impact or high risk AI bio. The recommendations that we've shared today are more granular than the tangent biosecurity guidelines. So we would take these up a level in maybe a more appropriate way for states parties to be able to share and promote them. I think that is that's one idea. And then also, this is really brainstorming, but if you think about the CBM, maybe countries could, have an expectation or know that one of the things that would demonstrate their compliance with the convention is that they have policies requiring the screening of DNA synthesis orders, so that they have a know your customer kind of policy or regulation nationally, and by having that, you're sort of demonstrating care around the use and sharing of those materials. Just a few thoughts.
Here, please. I also like to add a comment with Iran. The question thought. I mean, if you think about the current discussion regarding the AI governance, I think we are already at the stage that nobody knows what the best thing to do. But the open discussion at this moment is the crucial topic for me. In terms of the what can be done, I mean, I can offer my own, sort of opinion. I mean, for example, almost all the agency and all major countries are thinking about what can be done to balance governance and also encourage the development of the AI. But each of the agencies do have each their interest. I just came back from the Convention on Biological Diversity meeting. There are also people there talking about what can AI and cause consequences to the work they are doing. So that would be necessary for the PwC, at least to me, and I think the scientific board or advisory board would be very crucial for people to examine what can be done here. Of course, I can think about my personal view is for some of the biological weapon novel way using AI to generate the new way to generate a bioweapon, and which are not very well governed. Could be something to start with. There are many things can be done along that line, but of course that's only the sort of personal view. But the open discussion is the thing we really need to do now. Yeah. Okay, that's the first question. The second question is regarding the incentive, right? It's just actually, okay, let me give it a try. I think one of the things we learned is, when people started to talk about governance of AI, I mean, we have very high hope with the AI demand, what can change the world. But the issue is some of the leading activity or mostly in the industry, I think both in China and in the US. A lot of very exciting work are done by the industry rather by the academic. And so, but at this moment, very few of them are actually making money through the AI. I can tell you that probably US are a little better, but in China, most of the AI companies are not making money out of AI. So when we start to talk about the AI governance to those kind of people and in terms of and the responsibility and also for incentive for them, it's really, I mean, I sort of get some pushback from the industry because I mean they are still at the survival stage. And so what I'm thinking is you can think about at this stage, maybe mostly, I mean, in China, the central government probably needs to really put into the more incentive for companies doing that kind of work, which may not be the same in the US. That's just my thinking. Thank you.
Thank you, Wei. I think we have almost to finish. So, General Conrad, do you have any comments? You didn't get to answer. Okay, Anita, you can take us home then. I think that'll be our last remarks before we wrap up.
Just a quick comment on incentives. This would probably be mostly applicable to the academic labs and small companies that are making biological AI models. But for federal funding because most of them operate off of federal funding or sometimes venture capital. But there's you're familiar with LC, I guess, that each grant you would say you'd have to give you this grant, but 5% of the grant should be thinking through the ethical, legal, and social implications, LC, of this technology to kind of incentivize through like the purpose of the grant that those things would be considered. I don't know if that quite answers your question, but final thought.
Well, thank you all so much for spending some of your valuable time with us this morning. For those who were interested in finding out more or getting follow-up information, the QR code that's on the screen as well as the email. Nope, go back to where you were, Sean. Is the information that we're happy to share with you. Thank you so much. Cheers.